These notes are going to go over covalent bonding. So last class we talked about ionic bonds, and ionic bonds occur between ions. Remember, it occurs between positively charged cations and negatively charged anions. Covalent bonds, on the other hand, occur between a nonmetal atom and another nonmetal atom. So they basically occur between two nonmetal atoms. Now, the difference between an atom and an ion. So just really quickly, when we say the word atom, we are referring to an element that has no charge. So oxygen in atom form, if I'm talking about an atom of oxygen, it means that it has no charge and that it has 8 protons and 8 electrons. An ion of oxygen, on the other hand, means that it has a 2- charge and therefore 8 protons and 10 electrons. So atom means neutral and ion means that it is a charged element. So a covalent compound happens between two neutral elements that are both nonmetals. The attraction here occurs between the nucleus of the two atoms and a shared pair of electrons. So the nucleus is positively charged and therefore attracted to electrons. Now, what ends up causing the bond here is that for one atom that's attracted to those electrons, it's trying to hold on to them pretty tight. If another atom is also attracted to those electrons and holding onto them pretty tight, what ends up happening is that their valence orbitals begin to overlap. And so if neither of them are willing to relinquish those electrons, they are forced to then share them, and then their orbitals are therefore overlapping, and that is what the covalent bond is. So those shared pair of electrons are what are causing that covalent bond. That attraction to the same pair of electrons means that those two atoms are sticking together. So the reason that this happens between nonmetals is because nonmetals have high electronegativities. And remember, electronegativities have to do with how attracted you are to valence electrons, basically, or bonding pairs of electrons. I brought that up a couple of times. And so here we have what we're going to refer to now as our bonding pair of electrons. And so because this atom has a high electronegativity, it's not willing to let them go. And because this atom has a high electronegativity, it's not willing to let them go. So they're both holding on to that bonding pair of electrons super hard, causing the formation of this covalent bond. Now, covalent bonds, just so you know, you can have single covalent bonds, which are normally represented by 1 bar. Double covalent bonds are represented by 2 bars. That's 2 shared pairs of electrons, and then triple bonds are 3 bars. And we'll get more into that later on. The result of covalent bonds is the formation of a molecular compound. So you'll hear me say molecular compounds. That means that we're looking at 2 nonmetals that are covalently bonded together. Sometimes covalent bonds made between atoms are also referred to as covalent compounds. So you'll see that both terms are used pretty interchangeably. Example of covalent compounds are things like CO2, because these are 2 nonmetals bonded together. H2O, those are 2 nonmetals bonded together. What's another really quick one? Let's do, methane, which is CH4. Again, those would be 2 nonmetals bonded together. So these are all examples of covalent compounds or molecular compounds. We're not going to get into types of covalent bonds today. There are nonpolar covalent and polar covalent, but we'll talk more about those probably in quarter 2. So I'm just going to leave that blank for now, and we're going to move on to how do we name covalent compounds. So here are our rules. They're always going to be nonmetals bonded to nonmetals. So you'll see over here, this matches the periodic table that I have for you. So hydrogen is a nonmetal, and basically everything to the right of the staircase is a nonmetal. So here are our rules. When we are going from formula to name, we are going to write the name of the first element, write the name of the second element and end it in "ide," and then here's where it's going to differ. We are going to use a prefix to designate how many of each element exists. So here are our prefixes over here. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, hepta, octa, nona, deca. So these are the prefixes that we're going to use in our naming. So I'm going to follow the rules here, and I've got carbon, and hydrogen becomes hydride. And then I'm going to use prefixes, those are the ones that go before the word, to designate how many of them I have. So in this case, I have 2 carbon, and that's going to be di, so it's going to be dicarbon. And I've got 6 hydrogen, so I got to move this over, give me a second. So 6 is hexa, so it's going to be hexahydride. So dicarbon hexahydride would be the name of that first element. There are a couple of nitpicky rules. We don't use the term mono on the first element. So if we're doing CO, we know that that is referred to as carbon monoxide. We do not call it monocarbon monoxide because we don't put mono on the first one. So if you don't put a prefix on the first name, it's assumed that it's 1. All right, the second sort of nitpicky rule is if you get an AO when you add the prefix or an OO, you eliminate the first vowel. So just like I did with monoxide, it's not monoxide. I delete one of the O's and it becomes monoxide. So carbon monoxide. Same thing over here. If I got hexaoxide, I would eliminate that A and it would become hexoxide. Now, just so that we're super clear, we don't do this in things that are IO. You need to leave those in place. If I come up with an example in my head, I'll show it, but I can't think of one off the top of my head right now. All right. So I got one. So trioxide. So if you have a trioxide, you're going to leave that I there because troxide doesn't make any sense. So that's going to be trioxide. Only if it's an AO or an OO do you eliminate the first vowel. All right. So let's do our rules for going in reverse. Basically, we're going to take the last naming rules and we're just going to do it, but backwards. So instead, we're going to write the symbol for each of the names, and then the prefixes are going to be the subscripts. So for boron trifluoride, boron is a B, so I'll write B. Fluorine is an F. I see the word tri, so that means I have 3 fluorides. And boron has nothing, so it's assumed that it's a 1. Again, we don't write monoboron. So this is going to be BF3. There are a couple of diatomic molecules that happen in covalent compounds, and these are certain elements that when they are not bonded to something else, they form diatomic molecules, meaning molecules of 2. So if bromine isn't bonded to something else, or iodine, or nitrogen, or chlorine, hydrogen, oxygen, or fluorine, then they're going to form a diatomic molecule. So when I say like you're breathing in oxygen, that's because you're breathing in O2, because just O doesn't exist sort of in the natural world by itself. It will quickly bond to something else. So those are some of your naming rules. I mentioned the diatomic molecules because they will come up frequently, and if I say that iodine is reacting with something, I do need you to write I2. But if I tell you that something is, I don't know, like sulfur triiodide, that just means that it's sulfur I3 because that iodine is bonded to sulfur. But when iodine is alone, it will form a diatomic molecule. Just as a little tidbit too, there are 3 molecules that we use often that have common names. H2O is just referred to as water. You do not have to refer to it as dihydrogen monoxide. Let's see, methane is CH4, So you'll hear about methane a lot in the news because it is a greenhouse gas. And the last one is ammonia. These are all common names that you'll use frequently in this class. So I would just know these ones. And they don't follow the naming rules. All right, so I just want to do a couple practice since you're on your own. So we'll do number 1 and number 11 together. And then you'll practice the rest on your own. So the first one here is I've got hydrogen. And I've got fluoride. Remember, we still use "ide" at the end. And now I'm going to use my prefixes. So I have 1 hydrogen, but I know that I don't write monohydrogen, so I just leave it as hydrogen. And I have 1 fluorine, and I do use mono on the second one, so this becomes monofluoride. So that's hydrogen monofluoride. If I'm going in the other direction, remember you're going to write your symbol. So I have nitrogen and I have iodine. And in this case, again, no prefix here means that there's just 1. And tri means that I've got 3. So this is going to be Ni3. You are going to practice the rest of this worksheet on your own, and then we'll go over it next class.